Sometimes the universe sends us signs, quiet, fleeting, almost imperceptible. In 2025, a strange green spark appeared on the horizon, like a message from the depths of time. Who is this traveler? Why has it appeared now? And will we manage to see it, or will it disappear without leaving a trace? The first observers noticed it almost by chance. It seemed that the starry sky had long been studied thoroughly, yet suddenly something changed in the familiar pattern. Could this be a chance to touch a mystery that has been hidden from human eyes for tens of thousands of years? Or will the comet prove fickle and slip away at the last moment? What lies ahead? A grand spectacle or a silent deception of expectations? Soon, everything will become clear. Subscribe and like to make sure you don't miss anything. At the end of March 2025, astronomers Vladimir Bezegli, Michael Mattiazzo, and Rob Matson independently noticed a new object in images from the Solar Wind Anisotropies (SWAN) camera aboard the Soho Space Observatory. The first two reported the finding on March 29th, while the latter reported it on March 31st. Starting from March 22nd, the images captured a clearly comet-like object that was rapidly brightening. By March 29th, its apparent magnitude was around 11. At that time, the comet was located 1.62 astronomical units from Earth and 0.92 from the Sun, with a solar elongation of 28 degrees. After the reports were posted in Mike Meyer's discussion group Comets-ML, amateur astronomers began gathering additional data to calculate its orbit. The first successful ground-based confirmation occurred on April 2, 2025, when Ku Jiang observed that the comet's coma spanned about 2 arc minutes. Due to the SWAN camera's low resolution, the initial coordinates of the object had an error margin of about 2 degrees. The comet was named SWAN 2025 F2 SWAN and immediately attracted attention with its bright green color and tail. The green hue is explained by the presence of dicarbon, a special form of carbon in which atoms are linked by a double bond. The comet's orbit turned out to be nearly parabolic. Calculations using the epoch of 1800 indicated that its orbital period is about 80,000 years. Thus, for the past 40,000 years, the comet has been traveling toward the inner part of the solar system, starting from a distance of approximately 3,750 astronomical units, equivalent to 561 billion kilometers, or about 0.0593 light-years. Will we be able to witness the comet, or will it vanish without a trace, dissolving in the sun's rays? April 22nd saw the release of a new photograph of comet C2025 F2 SWAN, captured as part of Italy's Virtual Telescope project. The image shows the comet with blurred contours and no visible signs of a nucleus. This may confirm the hypothesis that it is disintegrating. Originally, it was expected that the comet would soon disappear behind the Sun, pass through perihelion, and reappear on the other side of the sky. However, even before this, observations became difficult due to its proximity to the horizon and the Sun. Not long ago, astronomers noticed that Comet C2025 F2 SWAN appeared unusually faint and diffuse. This suggested that it might have started breaking apart into fragments. The breakup itself was not unexpected. C2025 F2 SWAN is known to be approaching the Sun for the first time, and comets are essentially clusters of dust held together by ice, making them easily destroyed when heated. At that point, Most experts agreed that the comet had undergone fragmentation, with only the question remaining whether it had fully disintegrated or if some part of the nucleus had survived. The photographs taken on April 22nd provide strong evidence that the nucleus has completely broken apart. What might the destroyed core of the comet conceal? And how could this affect our understanding of the origin of the solar system? Could comets like SWAN be the key to the search for life in other corners of the cosmos? And what might they reveal about the possible conditions for its emergence? Comet SWAN is not just a rare celestial phenomenon, but also an important object for scientific research. Its nucleus, which may have already disintegrated, represents a kind of molecular-level clock. Each such body is a cosmic time capsule, preserving information about the earliest stages of the solar system's formation. By studying the composition of its coma and tail, astronomers can learn which chemical elements were widespread during that distant era, when our star was just beginning to take on its current form. The diatomic carbon, which gives the comet its characteristic green tint, is a molecule that has long attracted scientists' attention. Studying it helps deepen our understanding of which organic compounds might have been prevalent in the early solar system and which could have played a role in the origin of life on Earth. Every particle of dust emitted by the comet provides valuable information for science, revealing not only geochemistry, but also offering insights into possible scenarios for life in other parts of the universe. Moreover, comets like SWAN can serve not only for studying the past, but also for future missions, such as the European Comet Interceptor project, which will be sent to even more distant comets to study them on an unimaginably large scale. This project, to be carried out by the European Space Agency, ESA, represents a unique mission scheduled for 2029. A spacecraft positioned at the Lagrange point L2 will wait for up to 3 years for the arrival of a long-period comet in order to study its features at close range. The maximum cost of this ambitious project is estimated at 150 million euros, excluding scientific instruments and launch services. All of this reminds us of the significance of discoveries, like the appearance of Comet SWAN, and how each new celestial body helps bring us step by step closer to unraveling the greatest mysteries of our universe. And if you want to stay updated on the most exciting space discoveries and upcoming missions, don't forget to subscribe to the channel. Many incredible stories lie ahead for us to uncover together.